Hi class, last week and today in class we worked on simple interest. Now we're going to be looking at some compound interest. So you're looking at the bright yellow page that says compound interest in your composition book. Okay, our compound interest, when the amount of interest paid doesn't change each year, circle that. When the interest doesn't change each year, it is called simple interest. That's what we've been working on in class. So when we have interest that every year it's the exact same thing, it is called simple interest, and we use the formula I equals PRT to find simple interest to the nearest cent. Then you find your total. The I is the interest, P is the principal or the initial investment, R is the rate, you have to change it to a decimal, and T is the time. So we're going to start with our first example. I equals PRT. Write your formula. I is the interest. We don't know how much interest we have right now, but we know that our principal is $300. So underneath the letter P, I'm plugging in 300. That's the initial investment or the initial amount of a loan. R is our rate. 8% as a decimal is 0.08. And T has to be time in years, so our time is 4 years. So our interest is going to be equal to 300 times 0.08 times 4, which gives us a total interest of $96. So the interest here is $96. Our directions said, then find the total. If we had $300 in a savings account that got 8% interest for 4 years, at the end of our 4 years, we would have a total of our initial principal, which was $300, plus $96 in interest. So that gives us a total of $396. That is the total. This is the interest. Interest is extra money on an investment or extra money you pay on a loan. Example 2 has $1,225 at 6.25% for 18 months. So we're going to write our formula. We're using I equals PRT. I is the interest, P is the principal or the initial amount, R is our rate as a decimal, and T is time in years. So our principal that we started with $1,225, the rate as a decimal is 0.0625. Remember, to change decimals to percents or percents to decimals, we move it 2 spaces. If you remember from Miss Little and Miss Knuckles' class, they use DP for decimals and percents. To go from a percent to a decimal, we go back 2 places. And then T is time in years. If it's 18 months, that's 1 whole year and 6 extra months, which is 1.5 years, 1.5 years. So finding our interest now, we're going to multiply 25 times 0.0625 times 1.5 or 1.5, and that gives us a total interest of $114.84. So there's our interest. Now we have to find our total. Our total is the amount we started with, or the principal, plus the interest. So we're going to add together $1,225 plus our interest, which was $114.84. When we add these together, we would get, 84 cents plus 0 is 84. In our ones place would be 9. 5 plus 4 is 9. Tens place, 2 plus 1 is 3. 2 plus 1 is 3, and 1. So we would have a total investment or loan of $1,339.84. Our last example, doing our interest, equals principal times rate times time. This time our principal is $820. 6% as a decimal is 0.06, and 6 months, we can do this 2 ways. We can do 6 divided by 12, which is 6 out of 12 months, or you can change that to 0.5. So 820 times 6 hundredths times 5 tenths or half. 6 months is half of a year. So we're going to multiply 820 times 0.06 times 0.5, and that gives us a total of $24.60 for our interest. So on this investment or loan, our interest is $24.60. When we look at our total, we add the initial investment or the initial loan to our interest. So we're going to add 820 plus 2460, which gives us a total of $844.60. So there's your review of simple interest. You will have simple interest on your test on Friday. Make sure that you're paying attention to how we find simple interest. All right, for the next section, when the amount of interest that is paid changes each year, circle that, it is called compound interest. This is typically what you will see in the real world is compound interest. So things like my savings account, when I put money in my savings account every few months or every month, depending on how your bank is set up, they put interest into your account. And then the next time they pay you interest on your interest. So here's how they're different. We're going to say we invested $1,000 with a 10% interest rate for 3 years. This is what's happening. This is how they're different. With simple interest, if we invest $1,000, we get 10% of $1,000, which is $100. So now we have $1,100, but we still only get 10% of our original investment, which would be $100 again. So we would have $1,200, but the next time they give us interest, it's only on the original investment, which would be another $100. So our total interest on this simple interest problem for 3 years would be $300 in interest. If we have the same investment, $1,000 with a 10% interest rate, and we look at compound interest, we're going to get paid interest for our interest. When we invest $1,000, 10% of 1,000 was $100. So now we would have $1,100, and the next time we get paid interest, we get 10% of $1,100. 10% of $1,100 is $110. So now in our account we would have $1,210, and we get 10% of that money. 10% of that would be $121. So now our total in the bank is $1,331. So we would get a total of $331 in interest. When you are investing, you would much rather have compound interest than simple interest because compound will always give you more. But if you had a loan and you were having to pay somebody, you would rather have simple interest because simple interest will always be less than compound interest if it's the same rate and time. So we're going to look at 3 examples. For each of these examples, we're going to find the total amount in each account to the nearest cent if this interest is compounded annually. For the first one, if we had a bank account that had $2,825 in it, and we're going to get 4.75% interest rate for 2 years, these are compounded annually. That means they put the interest back in the account every year. So the beginning balance in year 1 is $2,825. Now, to find the amount of interest, we're going to multiply the balance times our percent, which was 0.0475. We make it a decimal. So now $2,825 times 0.0475 gives us interest of $134.19. Let's round to the nearest cent. So at the end of the year, I have the money in my account and I'm adding, the bank's going to give me $134.19. So my new balance at the end of the year means I get to add those 2 boxes together. That's a total of $2,959.19. So at the end of the first year, I have my total in the account plus I have the interest that was paid. So now we're going to take this number and it's going to be our beginning balance for the second year. we're taking $2,959.19, and we're going to get 4.75% interest on this, so we're going to multiply by our decimal. Taking that number, $2,959.19 times 4.75%, or 0.075 as a decimal. This time I get interest for the interest they paid. We're going to get $140.56 in interest. Do you see how the second year it has more interest? So we're going to add that to our $2,959.19. So at the end of the second year, we have a total of $3,099.75. Now, there are two parts to this question. We want to know the total amount. So right here is our total amount at the end of the second year. This is the new balance after they've added interest. And the second year, I got interest on the interest. Now, the total interest, there's two ways we can find this. We can add together our interest for year 1 and year 2 to get our total, or we can take our final balance, our total at the end of the 2 years, and subtract what we started with. Both ways should give you the same amount. So if we add our interest from the 2 years, I'm going to add these two columns. $134.19 for the first year and $140.56 for the second year gives us a total of $274.75. So the second year we got more interest because I got interest on my interest. Let's look at our second example. This one we have an $18,000 investment or loan at 13% interest for 3 years, and this is compounding annually. That means they put my interest back in the account every year. So we're going to start with $18,000. That's the balance on our investment. That's the initial amount. To find our interest, we multiply this by 13%, which is 1/1300ths as a decimal. So 18,000 times 0.13 gives us a total of $2,340 in interest. So my new balance now means I need to add the balance plus the interest because they're putting the interest back in the account. $18,000 plus $2,340 gives us a total of $20,340. The second year, when the second year starts, that balance, the beginning balance this year, is how I ended the last year. So $2,340 is the amount of my investment. We're going to multiply this by our interest rate, 0.13. So $2,340 times 13% would give us an interest of $2,644.20. Do you see how our interest has increased this time? Because I'm not just getting interest on my $18,000, I'm getting interest on that and the interest from the year before. So our total altogether now, when we add $20,340 plus $2,644.20, gives us an ending balance this year of $22,984.20. So the beginning of year 3, in our account, we have $22,984.20. To find our interest for this year, we're going to multiply by 13%, or 0.13. It has to be a decimal. That gives us interest of $2,987.95. At the end of the year, I'm going to add that to my balance from the beginning of the year because the interest is getting put back in the account. And at the very end of 3 years, we have $25,972.15. So this asks us for the total amount if it's compounded annually. Our total amount at the end of 3 years is $25,972.15. I started with a balance of $18,000. So to find my interest, last time we added up the interest column, or I can take the $25,972.15, and we can subtract the $18,000 we started with, and that is another way it will tell us our interest. So if we take $25,972.15 that is in the account at the end of 3 years and subtract what we started with, that extra money must all be from the interest. So when we subtract that, it gives us a total interest of $7,972.15. So the total interest after 3 years is almost $8,000 on that investment. So the total is at the end of our 3 years, and the interest is the extra money that's in the account. For the last example, I want you to try this yourself. We have a balance of $580 at 11.8% for 4 years. So you're going to fill out your table, and then you're going to find your ending balance at 4 years and your total interest. Remember, to find your interest, you multiply by your percent. So we're going to multiply 11.8% or 0.118. And then you're going to add your beginning balance and your interest together to find your new balance. Your new balance will, at the end of year 1, becomes your beginning balance at the end of year 2. Tomorrow in class, we're going to work on a formula for this, but we need to know that compound interest will always give us more interest than just simple interest.